2021. At the onset, I want to thank SacHacks, Akshay, and the whole SacHacks amazing team for working with us here at IBM and for having us co-host this event. We certainly hope you're going to have a great weekend hacking, and we're eager to see all the amazing solutions you produce. I'd like to start with the short video. Chris, when you're ready, if you can hit it. Thank you so much. Every time I see that video, I am energized and enthused and reminds me of how much I love what I do, which is doing something that matters, working on something that matters. I'm gonna real quick share my screen here. Okay. Please let me know if you see my screen. Okay.
Yes.
My name is Sudarshana Srinivasan. I'm a program manager for IBM Z. I focus on community engagement and IBM Z advocacy. So when we talk about enterprise computing, what are we really talking here? We're talking about systems that are powering our economy, running the world quietly from behind the scenes. We're talking about things that need to happen in less than a second. So talking of a second, what does really happen in 1 second? We're talking about over 5,000 tweets and a little over 18,000 Tinder swipes. What else? 20,000 plus photos are shared every second. It seems like the world is always Google searching something or the other, right? So what does that add up to? 63,000 searches in 1 second. And that translates to 1,157,407 IBM Z transactions. These machines are built for throughput. These transactions have to happen in milliseconds. But wait, there's more. It's not just speed. We need to have these transactions happen with reliability and security. So what is this transactions that we're talking about, right? Like, let's take a quick look at the bottom of the screen here. We have a user engaged through what we call a system of engagement, their device that they want to use, perhaps shopping for, let's say, the latest game that they've always wanted. So they're on an app or the website of the merchant. They make their transaction. The app or the website is hosted on a public cloud somewhere for the merchant. They then in turn need to verify that the user is indeed who they say they are. They do have the bank balance and all of the to make that payment, right? So we're working through with the APIs that have been deployed on the IBM Z. We now come to that final enterprise network piece of the transaction. The IBM Z is sitting all the way in the back. And through these APIs, the bank has to now verify that indeed this user is who they say they are, they have the balance, and give back a yay or a nay to the merchant. And all of this has to happen in 3 to 4 milliseconds tops. So that's what we are talking about. And we're saying that that's 68% of the world's production IT workload runs on mainframe systems, which is these IBM Z machines. So obviously, we have all used an IBM Z. We're talking about 400 million retail transactions, airline reservations, hotel nights. So annually, 87% of all credit card transactions go through an IBM Z. So every time you click either on a website or at a store, you swipe a card, those are IBM Z transactions. Every time you take out your ATM card and go to the ATM, that's an IBM Z transaction. So think about that the next time you're making these transactions. And the fact is, there is demand for IBM Z and IBM Z skills. Couple numbers I'd like to point out here real quick. 90% of clients on the platform look at this as a growth platform and one where they're going to have long-term applications. And a very interesting one for today, especially, or for this weekend, 67% of them have majority of their data on the mainframe. You'll hear from our ML experts here in a little while during the ML on Z workshop from Joe and Alex, talking about data gravity and how important that is when we're talking about machine learning. What this means is this puts this platform as a naturally great one for machine learning. Enterprise computing obviously offers a wide variety of areas for opportunities for a career path. Hybrid cloud, analytics, AI, blockchain, just to name a few. So students, what's in it for you? A Forrester study showed that 5 primary things are top of mind for students in a potential career: good salary, work-life balance, ability to make a social impact that comes back to work on something that matters, and working on leading edge technology, finally, job security and that job versatility. And as you can see across the board, enterprise computing outperforms other IT roles. So, you know what they say about you don't know what you don't know. So I hope that today you've learned a little about IBM Z and enterprise computing and that you want to learn more. You're eager and excited and want to stay engaged. Join us today on our IBM Z Global Student Hub. The link is here ready for you, and I will also post it on chat and Discord. We look forward to seeing you there. As the video said, these are open source beasts and ready with machine learning. So I will, without further ado, hand it over to Javier Perez and Tanmay Bakshi, our keynote speakers. Thank you so much.
Thank you.
Thank you.
Hey guys, how you doing? I think I'm hearing a little echo, but it should be okay. All right. Really happy to be here. I always like to talk to students. Makes me feel like I was back in college, and unfortunately that was many years ago. My name is Javier Perez. I'm open source program manager for IBM. I'm part of the IBM Z organization. You can see my contact details there, and we haven't been in a concert in a long time, right? So I thought, well, let's put a picture there and feel like we are in a big event. I know there's a lot of people that register here. I'm sure we have a few hundreds or more than 1,000 people. So that's very, very exciting. I'm going to talk to you as part of this keynote. I'm going to talk to you about open source software. Maybe a little bit about IBM Z. You already heard a really nice introduction, but it's all about open source. And my goal here is to get you excited about doing more open source. All right. So let's get started. We are in a place where we are innovating, right? We are every innovation out there. It's in the open. You can go to GitHub repos. You can go to any repo and read the code and see what's happening, right? Augmented reality, virtual reality, autonomous cars, of course, AI, ML, deep learning. You name it, it's all being developed in the open, and that's exciting, right? I mean, you can go and learn, you can go and check the code and build on top of what it's done already, and it's all open out there, right? And of course, all the programming languages and all the the frameworks are open source as well, right? So that's great. We have the building blocks to go and innovate and build more, and everything it's open source. So if you don't believe me, look at these numbers. We just passed the 210 million repos in GitHub, right? I don't have the exact number for how many of them are private repos versus public repos, but more than I'm sure that more than 50% of them are public repos. Anyone can go and read the code there. GitHub just announced, Microsoft GitHub, they just announced that they passed the 56 million developers or 56 million users of GitHub. So open source is huge, right? It's here to stay. There are products like SourceForge that help you open source your code. Well, they have more than 500,000 projects out there. And these are serious projects that they have contributors, that they have more people contributing, and they're just innovating, right? So let me give you more numbers now. The foundations, right? It's very important especially when open source projects get really getting traction, and you get more users, and then you get companies that start to use that open source. You need to have a place where people can discuss and then drive direction, drive a roadmap for that open source project. So there are many foundations out there, open source foundations. The most popular, so some of the largest are the Linux Foundation, the Apache Foundation, the Eclipse Foundation. If you're not familiar with them, I recommend you to go check their websites and ideas. And if you have a good open source project, you can become part of their incubators programs, and then then you can graduate your project. And most of the most successful projects out there, obviously Linux, Kubernetes, and others, they are part of these foundations. And look at these numbers. Just the last one with numbers. If you are coding on Node.js or JavaScript, if you're coding on Java or Python or .NET, look at the amount of data or the amount of code that it's out there for you, right? Packages, libraries. Look at those numbers, right? More than 1.5 million available packages on NPM. More than 376,000 on Maven. If you need any library that you don't need to start from scratch, you go and take the library from out there. But I'm more impressed about the numbers that you see at the bottom there, where it says the number of packages per day, right? More than 207 Python packages per day, new packages per day. They keep adding. I actually update this slide every few months. I updated this very recently, February 1st, from modulecounts.com. And if you go and check right now, the numbers keep growing, right? So it is just amazing how much open source has grown. Now, if you're thinking, well, all right, well, this is all good. These are all my own projects. I can work on this on my own time, after school or after work. Well, guess what? It also can become a big part of your career. So IBM actually commissioned a survey for 3,400 developers and developer managers on businesses, on enterprises that have developers. So they basically went and asked what we call professional developers, right? People that live out of coding, and including managers. And look at these numbers, right? 95% consider that open source software is better than proprietary software, right? There's no question that it's better because you can keep innovating, you can keep adding and doing more. 87% developer managers say that open source knowledge is a factor of hiring decisions, right? And 65% say that I agree that if you work on open source projects, you will impress your employers or potential employers. So if I haven't convinced you there that go and invest time and learn and innovate, let me give you a little bit more of information. And for some of you that are also new to this, and I'm working with right now. I'm working with all college students from a different university at the moment, and they're very new at open source. They really want to learn, but they don't know the steps, right? So, it's all about consume and contribute, right? Everyone says, oh, it's free, I can just take the code, right? And yes, and you can even monetize that software, right? You can build on top of that and create a business. But you can also contribute, right? And it's the concept that we call an IBM, the be a good neighbor, right? So not only just take downstream, but also go and help contributing back to that project, right? innovation, that's how you innovate. That's how you fix bugs. That's how you improve the quality. That's how you improve the security. That's how you address vulnerabilities, for example, right? So meaningful contributions. Someone said minimum contributions. It really fosters a community, right? So I invite you to take action, right? If you are a developer and you can create or just review, or very important to review the open source license file, right? See what kind of permissions, how much you can do with that software, and of course read the different guidelines and the code of conduct. In terms of contributions, right? As I said before, just bug fixes, vulnerabilities, but also enhancements. You can port to multiple platforms like the IBM Z platform, and it's not just code, right? You can help open source projects doing testing, writing documentation, translating. You can see there on the different bullet points, but there's so many ways that you can participate, right? And of course, a hackathon, it's an ideal place for you to start, open source that, and then maybe get some more contributors, some more people that like what you're doing and want to kind of build from there. So ideal place to start on a hackathon, then open sourcing that code. We're talking about IBM Z, and you might recognize some of these logos, or most of these logos. All of these represent open source software. Probably some of the most successful, most recognizable open source software out there. All of this, it's available on the IBM Z platform, IBM Z and Linux One, all of this. And we have a great program here to do and do machine learning, right? Doing AI, machine learning use cases. So I said, well, let's just show you what's the ecosystem for machine learning, data and AI landscape. I don't expect you to read all these logos, right? But this was put together just recently in September 2020, and this represents all the ecosystem, or at least a good part of the ecosystem for data and AI landscape. So you can read, well, let me just zoom it a little bit, just to talk about open source. And again, you'll recognize many of these logos, and most of you, but maybe you already using that. If not, just taking a look, you can use them and then build something really, really good, something really, really interesting, especially around AI, machine learning, deep learning use cases. I did a quick analysis on what the companies, as you know, IBM has a lot of customers, a lot of enterprise customers. You saw on the introduction that most of the transactions, financial transactions, payments, credit cards are happening on the IBM Z platform. So I went and checked, all right, what open source these large financial institutions are using. What open source, especially related to machine learning, what open source they're using, right? So from your point of view, well, maybe these are the different software, the different tools, the different libraries, the different scripts that you could learn to maybe a potential future on a financial institution. So these are what you read there, from Python to TensorFlow to PyTorch. This is an analysis. This is kind of an average of all the different open source projects that are using on actually the top 8 financial institutions in the world. They are all using this. They are acquiring also startups. They're acquiring fintech, and they're using some of this, or at least these are the most common open source projects that you're using. So I thought that would be a good information for you. And just to end this session, I want to end with some fun use cases. Some say, well, maybe it's not going to give you an idea for your project right now. Maybe yes, but if not, at least you'll learn something cool, something new. Some stuff that it's been done with IBM and machine learning. So first of all, the US Open, as you know, all last year with the pandemic, a lot of events were canceled, and the Open Wimbledon got canceled, but then the US Open were going with a delay, but got going without fans on the stands, right? So there were 3 very interesting machine learning based use cases that were put together. One was what they call the fan open debate questions. So people will post questions and go into debates online, but with machine learning, they were processing more than 40 million pieces of unstructured data, basically news, articles, all the information that it's online. And then it was part of the debate. So it would answer you with the pros and cons on everything that you were discussing, right? So there was a lot of participation in that feature, that game. Then the fact sheets was also very interesting, right? You could go before any match, and then it will generate a fact sheet for you. It will go and scan, or it will process information for 14 million articles, and give you, all the information about, how they've been playing against each other on the different surfaces and so on. And then finally, the noise broadcast, right? The kind of analyze based on previous plays and how the crowd reacted, so they can play it for the highlights. So I thought this was really, really cool. And this is about machine learning. This is about processing, millions of pieces of information. Another fun use case, some of you might be actually users, right? Might be playing ESPN fantasy football. So we are actually with IBM and what is called Watson AI, really processing and providing information, right? Providing what is called insights. More than 25 billion insights. That means pieces of information to help you on your fantasy team. really, it's read and comprehends hundreds of millions of articles, so you can get information about your trades and about who's gonna do better than the other, right? And if you want to trade players, what will be the fair market value? All of that behind the scenes, it's done with machine learning. And finally, my favorite. This is the third one, and my favorite. Very few people know about this. All of you probably heard about autonomous vehicles, right? Autonomous cars. Well, this is an autonomous vessel. So this is a project that this year, I think later in the spring, it's going to go at this vessel completely on its own, right? With a bunch of cameras and radars and sensors, and of course trained by for more than 2 years with machine learning models, to go by itself from Plymouth, UK to Plymouth, Massachusetts. And of course, they're going to go and extract and capture a lot of data and really become a really, really cool project, gathering information about the trip and gathering information about how to react on certain hazard situations. Really, really, really cool. I recommend you to go and check it out. It's mass400.com/technology, where you can see more. So finally, I think you got this, right? I'm super excited about open source, super excited about you guys working on a hackathon. All AI, it's open source. Go consume, but also contribute to open source, and go and build something great, right? Well, thank you very much. Good luck on the hackathon. And best of luck.
Wonderful. All right, now I will get started. I think there were a couple of questions for Javier that I think he wasn't able to get to, but still, though, glad to be here now and get to speak with you all. I mean, what Javier talked about with open source technology is definitely something that excites me a lot. But I'm going to take a little bit of a different angle. There's something that I want to talk about today that hits a little bit closer to artificial intelligence and machine learning technology. So just really quickly to start off, I'm going to share my screen, so hopefully you can see that now. All right, let's just make sure you can see it. There we go. Yes, you can. All right. Oh, there we go. Now you can see it. Right. So hi, everyone. Thank you very much for joining SacHacks 2021. I'm really excited to be here myself. My name is Tanmay Bakshi. And also, just to sort of, before we get into machine learning and artificial intelligence and all this technology that I'm really excited about, I do just want to quickly start off by answering, a question that I'm sure everybody's probably wondering. Why am I here? And really, the reason that I'm here is because I love working with technology. Right, so I absolutely love being able to take powerful technology, like, for example, artificial intelligence, machine learning, and other kinds of technologies, and applying them to solve problems, right? So being able to leverage these technologies to solve the world's problems and augment human lives, but then also from there, enable other people to use that technology to do the same. So then from there, being able to provide, for example, developers with the resources that they need in order to actually use that technology to solve the problems that they see, right? That's what I'm really passionate about. And throughout this sort of journey of leveraging and building different technologies, one particular sort of key area of interest for me has always been artificial intelligence technology. And the reason that artificial intelligence is so exciting to me is because of the unique capabilities that it really unlocks. As a matter of fact, personally, I think that AI, even though we call it artificial intelligence a lot, I think it's better called, for example, machine learning technology, and I'll get into why in just a moment. But first, to give you a little bit of context as to why machine learning excites me so much, I want to tell you a little bit more about how exactly I sort of got into that world of AI in the first place. I'll keep this brief, but basically the idea is that a couple years ago, say around 6 years ago when I was like 11 years old, of course I was working with technology back then, but technology wasn't really that exciting to me. And the reason for that was because I felt like there was something missing, right? Like computers can only really do what we explicitly program them to. And when I was 11, I had, by complete chance, stumbled upon a documentary on IBM Watson and how it won the Jeopardy game show against the two best competitors on the show. And that immediately intrigued me. I was absolutely fascinated by how, my mindset went from computers are extremely rigid and cannot do anything except for the programs that we, code manually, to now seeing how they can be flexible and understand something as complex as Jeopardy clues, right? Being able to comprehend those clues and then provide valid responses more accurately than humans is absolutely incredible. And that particularly piqued my interest in the world of language, because language is infinitely complex, right? It's something that's unique to humans and the way that we operate and communicate. And so ever since then, I've been incredibly fascinated by the world of machine learning and AI, but also language, natural language, and how you can process that using technology. And I think that artificial intelligence is powerful enough that even though it might be simple at its core, I think there are a lot of misunderstandings about it. As a matter of fact, I would go as far as to say that machine learning is the most misunderstood technology on the planet today. And really what I mean by that is there are a couple key sort of misconceptions about AI that I feel like a lot of people have. Like, for example, artificial intelligence is meant to simulate human intelligence in a way, right? It's meant to take the way that our brains work or the sort of high level structure of natural intelligence and simulate that within technology. But that's not the case at all, right? It's fundamentally pretty simple math, function optimization. We then take a look at another misconception, like, for example, the fact that a lot of people think it's about replacing human jobs. That's also not the case, right? Really, technology like AI is meant to augment humans. Automation just happens to be a side effect of that. And there are a couple of jobs that will be automated, but really the goal is to use machine learning to augment human capabilities. And at the same time, we also happen to believe that AI is about surpassing human intelligence, right? So sort of combining those last two misconceptions into one, people believe that AI is about making humans obsolete altogether. But that's also not the case, right? Technology is still narrow. It's just more flexible within a narrow window. And so we don't need to program, really, really low-level rules manually. That's the idea. We want to automate that portion. And these misconceptions sort of surface, I think, in a lot of different interesting ways. For example, you might see some really, interesting news articles like this one. And as a developer, I look at these and I think, no, that's not how it works. So for example, there's this really famous news article, "Can artificial intelligence replace songwriters? Study on AI lyrics suggests it's possible." Now, of course, as a machine learning developer, as someone who actually works a lot with natural language processing, I know that no, it's not going to. Creativity is fundamentally still a human ability, right? This isn't something that we can replicate with machines. But still, there are all these kinds of, news articles and hype or on social media around how, for example, OpenAI's new GPT-3 or all these different neural networks are going to replace humans in practically every industry, from like coding and cooking to songwriting and journalism. And so, based off of the inspiration from this article and others like it, I actually set out on this journey to build a system that uses artificial intelligence to sort of prove how you can augment songwriters, enable them to do their work more efficiently, and really, I think, extend that to creative professionals in general. And then from there, prove how machine learning isn't meant to replace them. It's meant to help them, right? Be more creative and to essentially eliminate writer's block by providing automated inspiration at scale. That's the idea. And I knew from the very beginning that obviously this was a huge challenge, right? This is not easy in any way. And I feel like to really understand what makes it so complex, it's important to take a look at just the scope of the task, right? So for example, you take a look at a simple verse like this one, I mean, I say relatively simple verse like this one, and even just understanding like the second line requires so much knowledge about humans, right? It requires us to understand that humans are animals, specifically animals that need sleep. And in this case, this person's not getting any sleep. Tylenol's a medicine. It's meant to help you sleep, but it's not working in this case. And what does it mean that it's not working? In context, all of these links have to be made. And then what makes it even worse is that it's not even just simple natural language understanding and also generation. You also have to take into account that art is up for interpretation. Right, so for example, this is a raw generation from the network. Actually, I did not edit this at all. The system that I built generated this from scratch. And any sort of classic machine learning based natural language processing system might say that the third line doesn't really make that much sense, right? How can you see with your hands? But at the same time, within the art world, that technically can happen in a way, right? It's like this can make a lot of sense in certain contexts. So it really depends on what message you're trying to get across. And so there's all sort of layers of complexity, but I'm glad to say that I was able to build the system, which I call Auto Lyricist, which I will be posting a couple of demo videos of in the IBM Z channel on Discord for SacHacks. So make sure you do take a look at that. Unfortunately, we don't have the infrastructure or time actually to play those demo clips today, but there are two video clips of actual music that I've produced with the help of some very talented singers and producers to really show off what Auto Lyricist is capable of. So please do take a look at that at the IBM channel on the Discord. But something that I do want to talk about, and the reason that I'm bringing this project up today, is I've always really believed that in order to innovate, you really need to start from the lowest levels of the stack. In order to really make a great user experience, for example, or solve problems, you can't just use the tools that you readily have available and just try to apply them. It's important to go down and understand how to make those tools themselves better or invent new tools. Right? And I feel like a great example of that might even just be the transition that Apple's been making recently from Intel chips to their own Apple Silicon chips. And the reason that I think that's a great analog, or an analogy, is because if you think about it, at a very fundamental level, no consumer cares what chip a computer is running. What they care about is there's better battery life, it runs cooler, so I don't need to have a jet engine on my desk, and it's not burning my lap, and so on and so forth. There's performance advantages and so much more. I can run iOS apps on my Mac now too. Right, so no consumer cares that we're running an Apple Silicon chip, but what they care about is the user experience that enables. And without that very fundamental low-level change of switching, for example, instruction sets and CPU fabrication processes and so much more, without that low-level innovation, high-level innovation would also be impossible. And so that's precisely why I bring up this project today, because this is a complex project. It requires all kinds of steps to be done in all kinds of ways in order to get this sort of symphony of different neural networks and machine learning systems to actually work together. For example, as you might know if you have some experience with machine learning, specifically deep learning, training these neural networks can get really intense. And so you might need GPU power, which is why I use Nimbix, which is this great high performance compute in the cloud sort of provider. And I use specifically IBM Power machines with GPUs, NVIDIA GPUs on them, in order to train these neural networks to actually get them to work on massive data sets. And without that, training these systems would have been absolutely impossible. But then from there, there's also this huge need for a bunch of different, for example, queries to be run as inference against these models at runtime, right? To be able to generate tens of thousands of verses or choruses or bridges or so on for songwriters to actually help them. And that's where IBM Z comes in, which is what we're talking about today. IBM Z is this sort of platform that is built, as we've talked about today, for enterprise computing. And enterprise computing probably isn't something that you maybe think about every single day, but enterprise computing is what powers a lot of the amazing things that we almost take for granted, right? We've talked about banking and those sorts of transactions. And when you go to the airport and you check into a flight, you're more than likely in some way throughout that transaction using a mainframe at some point. And so what I think is important to realize is that getting started right now with using these different, architectures and getting used to these low-level tools is going to be really helpful later in your career and even now, as you build technology. Even just for this specific project, I used like 4 different CPU architectures. I think this is pretty much every major CPU architecture out there today, right? So for example, my personal MacBook Air, which I'm doing the stream on right now, and I use to actually access the different machines for training and inference and so on, that's an ARM machine, right? A lot of the data scraping that I needed to do to get my data from Genius, that happened on an x86 machine, an Intel machine on IBM Cloud. If you take a look at the training for the system, happened on Power, happened using GPUs and their fast interconnect with the Power systems, using the NVIDIA Teslas. And finally, of course, the inference, actually generating the data that songwriters would then use to figure out what exactly they want to write. That was done on IBM Z, right? Using that sort of inherent scalability and that sort of speed that I get with it. And so technology, of course, is incredibly powerful. It can help you solve all kinds of problems, but making sure that you understand the tool set that you actually have at your disposal, and then being able to innovate on those tools, create new tools, and then apply those tools to solve problems, I think really is the key. And so that's what I wanted to share with you today. Once again, momentarily, I will be posting the link to those 2 demo videos, so please do feel free to check that out. And remember that all the lyrics that you hear were indeed generated, or at least mostly inspired, by this neural network running on an IBM Z machine. So, of course, feel free to contact me on any of the media you see online or on screen right now. Also, I believe we can take questions now, so feel free to put them in the chat if you'd like to ask me any questions. And also feel free to connect with me on Discord. I have joined the server. Post messages in the channel or message me directly, and I can answer your questions. But yeah, let's see if we have any questions in the live stream chat now. And I would love to answer them. Let's take a look. Okay, I'm going to stop sharing my screen. There we go. Okay. So first of all, there is a question. I'm interested in AI, machine learning, and natural language processing, but it seems that the learning curve is too steep, is very steep. So any tips on how to start? Great question. So I think artificial intelligence, machine learning is something that looks a lot more complex than it actually is when you start to dive into it. So one thing that I will say is, don't be afraid of this technology, right? It's not as complex as maybe it's made out to be. A great way to start would be, I think, Cognitive Class. Cognitive Class is an online, free courses platform where you can take a look at, for example, the AI and data science learning path using Python. I think that's a great way to get started, as well as a playlist that I have on my YouTube channel, actually, called Learn Deep Learning from Scratch. Now, once you've learned those sort of base machine learning AI techniques, then I think it would make more sense to get into natural language processing in specific. I feel like that's more of an application of machine learning as much as it is its own field, right? You can always learn things from the world of vision and audio and apply it to language. So I think that's really important. So I also see a question, does AI have a brighter future than all other tech careers since it has such a broad spectrum? I will say technology in general is not necessarily even its own industry. It's really its own, it is really the infrastructure for every other industry, right? And so I feel like technology in general is that broad spectrum, but artificial intelligence, unlike a lot of other next generation technologies, covers that entire broad spectrum, right? You look at blockchain and it covers a very specific niche. Cloud also covers a pretty broad spectrum, but then you take a look at things like IoT, pretty niche. AI is one of those next generation technologies that actually does cover that whole spectrum that technology in general does. Because wherever you have data, you'll want to use AI to find insights in it. So I will say that generally, I think AI is more wide in scope, but that doesn't necessarily mean it has a brighter future, right? It depends on what you're interested in and where you want to apply technology. All right, so another question. I'm going to be a little bit brief with these ones because I want to be able to cover these all. They're really interesting questions. Any benefits to using the RISC-V or RISC-V? I've never really learned the pronunciation for that one, but I believe it's RISC-V architecture compared to x86. Now, I have looked into a couple of different architectures. I mean, my favorite sort of comparison being the one between ARM and x86, how people, there's this misconception of ARM being a mobile architecture, even though it really fundamentally doesn't need to be just a mobile architecture. And so I think x86 in general, despite being the most popular one, isn't necessarily the best. I think there are lots of disadvantages to it. In terms of RISC-V in specific, I personally haven't done a lot of research into RISC-V. I've taken a look at RISC-V assembly. I've helped out some people with coding with RISC-V before, but since RISC-V isn't popular, really accessible right now, since you can't just go online and buy a RISC-V machine, it's a little bit harder to actually get experience with it. So I'm not exactly sure of specific major benefits to RISC-V. I do know that from a fundamental perspective, there can be some benefits, like for example, the fact that you're running a RISC architecture, being able to have theoretically faster CPUs if you implement them the right way, and so on. So I think it really depends on the task and the specific implementation of the RISC-V architecture. But that is a really interesting thing that I will look into further. Another question. You say that machines can't replace human creativity, but they can augment it. What's the difference? That, I think, is a really interesting sort of the reason I think that's an interesting question because that raises up the another question of what human creativity really is. And I think the best way to put it would actually be from a tweet. I'm unfortunately forgetting who the tweet is from, but I'm sure if you search for it, you will get it. And that is that, for example, with GPT, right, this neural network that OpenAI trained to generate text based off of internet data, if you were to just use GPT to generate the internet for the rest of time, right, no more humans, the internet would stay the same. There's a finite amount of stuff that GPT can do because GPT cannot evolve the internet, right? It can be creative in the sense of whatever it knows, that snapshot of time, it can recreate that snapshot really well, but it won't be able to evolve into new cultural phenomena and so on like humans can. Right, that's the difference. If I'm a songwriter and I want to just write exactly what already exists, just a new incarnation of it, I'll just use the neural network and not do anything. I'll just have it do it for me. But when it's augmenting me and when it's enabling me to be more creative, what it's doing is it's giving me content that I can then work off of and invent new kinds of content from as well. So the idea is that being able to really push the boundaries of creativity and what we can do in the data that we generate, that's where human creativity comes back in. That's something that machine learning can't replace right now. Right, and another one, any specific benefits of using IBM Z versus something like AWS? And also just really quickly, before I answer that question, there was another question that I think I saw about the what does the Z in IBM Z stand for? I did not know this previously, but I looked it up, and the Z stands for zero downtime. So that's exactly going to be the answer to this question, is IBM Z is fundamentally different from what you might get on, for example, in AWS. Also, I feel like it's a bit of a weird comparison. It's like comparing apples to oranges because Z is a specific compute architecture and platform, whereas AWS is an entire cloud-like environment. But if you were to talk specifically about, for example, the virtual machines that AWS offers, they provide, for example, x86 and ARM machines, as far as I know, their own actual custom ARM machines on AWS. And depending on the task that you want to do, you might want to pick Z or something on AWS or IBM Cloud or Google Cloud. And the reason for that is because, again, you don't just want to have a tool and use it just because you want to use that tool in specific, right? IBM Z has specific advantages, like being really, really reliable, right? With downtime measured in literally decades, and being extremely, extremely fast, right? Being machines with few cores, but cores that run incredibly fast. So if you have a task that calls for something like Z that needs to be just, absolutely mission critical, reliable, being able to time it down to the millisecond, that's where you want to use an IBM Z. In any other case, it's usually not necessarily cost effective to use IBM Z, and you'd want to use an AWS or Google Cloud or so on. But there are lots of use cases, machine learning being one of them, thanks to the data gravity that we were talking about, wanting to move algorithms where the data is located, that IBM Z makes sense. So hopefully that was helpful. Again, any other questions, feel free to message me on the Discord server or post your questions in the IBM channel as well, and I would be glad to help out. So thank you very much, and goodbye, everyone.